Hello and welcome. My name's Mary Napolitano, and I'm the product manager for Linac View here at Standard Imaging. I'm also a physicist. Let's go over a bit of housekeeping before we get started. Today's webinar will be recorded. Please enter questions at any time during the presentation in the GoToMeeting dialog box. I will answer all questions at the end of the presentation. Standard Imaging is based in Middleton, Wisconsin, and founded in 1989. At Standard Imaging, we design and manufacture a full suite of QA products. So during my presentation, I'll begin with an overview of the basic workflow, then provide a bit of background on log files and how and why they are useful for patient-specific plan comparisons. In particular, the fluence comparison is useful when alert criteria, for example, for pass-fail, are used. These can be based on gamma calculation criteria. We also have the delta and chi criteria, should you prefer those. I'll show some examples of specific plan fluence analysis, and then I'll discuss a few recent publications comparing log file versus detector array comparisons to show that correlations exist and differences in what errors can be seen and which picks up those errors more effectively. Finally, I'll review some of the new features in version 3.8. So here's the basic workflow for LinacView. Everything begins with the RT plan. So the RT plan is exported from the treatment planning computer, both to the Linac console and as well to an RT plan folder. This RT plan folder is then monitored by LinacView, and those RT plans are imported and waiting to connect those RT plans to log files that come through the Linac. So once the plan is delivered on the Linac, log files are automatically generated and saved to a batch folder that a log file is that our Linac View is automatically syncing to as well. And so when those RT plans are matched to the log files based on criteria that we set up in the software, then alerts and failures can be generated if necessary. Of course, if they pass, no alert or failure is produced by the system, and the pass is recorded as well. And then if one would like to analyze those log files a bit further, one can generate RT plans. And those in previous versions could be manually generated. And a new feature that I'll go into a bit further is the auto plan generation. And so that you can automatically generate and save your RT plans into this generated RT plan folder. And you can then, of course, automate that process to perhaps send it into your treatment planning computer again to recompute there and compare using your familiar and commissioned treatment planning system to compare the planned versus the delivered RT plan. Or, of course, you can link that to another third-party independent dose calculation engine as well, your preference. But it's a very direct comparison when you use your own treatment planning software so that you can see only the differences that are produced by differences in the delivery. So log files, let's step back and talk about some log file background. So log files were initially generated, as log files are, for any software to record what's happening. And here, of course, we record the delivery based on the feedback mechanisms designed into the Linac. Items such as, the monitor unit, MLC positions, etc. And initially, they were primarily and only used by the Linac engineers. But there's really a wealth of information in those log files, so why not use it? There are different types of log files dependent on your Linac type, and these log files, are gathered at different sampling rates, dependent on your Linac type as well. So log files, we've collected the log files at whatever rate your Linac is able to acquire those log files, and then we can use those to make direct comparisons of the multiple parameters that are collected. And these parameters are things such as the jaw position, carriage positions, MLC leaf positions, gantry collimator angles, monitor units, beam states, cable positions, and angles. And so as a clinical physicist, what do you do with that data? How do you determine if you, in fact, are impacting a clinical difference? So one of the things that we can do is calculate the delivered fluence based on the MLC leaf positions and the monitor units. Of course, you can have all the other parameters monitored as well, but a clinically relevant metric is the delivered fluence. And so then one can use that fluence and compare it to the fluence calculated by your treatment planning plan. So once one understands the information coming from the log files, the next step is to be able to map the log files records to the RT plan control points. And, this is a very important step. And depending on your Linac, we have different options for mapping those control points to the log files. I already mentioned that the same fluence can be performed based on the RT plan, such that a direct 2D fluence can then be analyzed using the traditional gamma analysis between the planned and delivered treatment. The RT plan specifies delivery based on control points, and only at these control points is the configuration specified. And so the assumptions in the treatment planning system and, at all times is that, there are control points where we specify positions of leaves, total composite monitor units delivered. And we assume that the leaves move uniformly between these control points, and the monitor unit dose rate is delivered uniformly between those control points as well. So the direct analysis that we can do in this manner is highly sensitive to catching errors. I'll touch briefly on some recent publications in the area later in the presentation. And of course, if one is interested in investigating further, the specific RT plan can be produced, and you can set your criteria as well, so that you can produce it with the same number of control points as the original RT plan, additional numbers of control points, and then you can even review and see how closely those generated RT plans match to the RT plan that is generated, the RT plan that is generated with a few control points matched to what the log file specifies on a very granular level. So the fluence comparison maps, I'm going to transition into what those fluence comparisons look like now. So we get a fluence comparison map from the RT plan, and then we also calculate a fluence map from the log files. We use a gamma comparison in order to create our alerts and failures. This particular plan, you can see, has a gamma index of 2%, 2 millimeter, with a cutoff of less than 5%. You can see that we have a gamma pass rate of 99.7%. And these fluence maps are created by projecting the MU-weighted segments to the isocenter plane. This, of course, exceeds a threshold, so no action is required. And so what do we expect for the alert and failure rates? So here, this fluence map shows 100% gamma pass rate, again at 2%, 2 millimeter, with a 5% cutoff. And, you know, it's really as expected. If you have a well-commissioned system, keep up with your machine QA, the vast majority of plans will not generate any sort of alert. One gets confirmation as each session is delivered, and then a summary report's generated when the treatment ends. In general, good results are not surprising because we don't have finite space detector grids, alignment errors, you know, just from the setup of an external measurement device, for example. But of course, we perform QA in order to catch those problematic plans. And in a typical clinic, if you're doing your QA, your Linac is well maintained, you will not see very many alerts and failures. But, you know, we want to do QA so that when one exists, we will catch them, and catch them with the minimum amount of work from the physicist side. So here's a sample failure case, just so you can see what tools are inside of Linac View in order to figure out what's going on. And I certainly won't go into detail concerning all the tools that are available. So this is a head and neck plan. It's it's a very complex plan with a modulation complexity score of 0.074. And what we see is a fluence failure. And you can see this area through here in yellow. Everything above gray is a failure. The blue area is just you know, below the 5% threshold. And so you can see along here, it looks like perhaps, you know, there's some leaf movement issue going on. And you can see in the histogram the failure region. Of course, the gamma pass rate is below our set criteria. You can also see here that the mean gamma is 0.495. But just a few things that you can look at. You can take a look at what's going on with the leaves. And so here we can look at bank A and bank B. In red, these are the leaves that are in failure regions. The green is in the pass region. You can also look here. The line here at the 0.75 is the alert. The red is the failure. And you can see for this particular case, the RMS failure exceeds in a large number of leaf pairs. As well, if you want to go, you can also, you know, go into Linac View. Certainly, you don't have to do this. You would only do this if you see a failure or you want to investigate further. You could also go in and look at specific leaf pairs. And here we're showing leaf pair number 10. And this is as the RT plan control points proceed throughout the plan. You can see where there are some problems with this leaf pair number 10. So a lot of information. But just to be investigated if you get an alert or failure. So now I'd like to transition into some recent publications. And this one is from May of 2021, an investigation using log file analysis for automated patient-specific QA. I'll talk a bit more about this one on the next slide. And then by the same group, there's a second publication that I wanted to point out that where they do QC of their log files, and that's an interesting read as well, in case you have concern that your log file is not a good mechanism to get those measured values from your Linac. This is a nice publication for you to read about using log files for patient-specific QA and how you might want to QC your log files. So the initial paper that I was referring to is published in, JACMP. And I wanted to describe for you a little bit about this study. There were 220 plans delivered on an elected Unity. These plans were analyzed using Linac View and measured with a commercially available detector array. 30 of those plans were incorrectly matched to check for error detection sensitivity. And so I wanted to show you the comparisons for the 190 correct plans where the gamma was set to 3%, 3 millimeters. The detector array came up with results of around 72% to 100%. Linac View came up with 95 to 100% pass rates for those correct plans. A few important details about that. So the detector array did find some commissioning problems. So as I stated before, this is a good patient-specific QA system for a well-commissioned system. And so this was, these were early plan deliveries and comparisons, and they did find some commissioning problems with, in this case, with the Monaco couch. This is a sort of error that Linac View would not catch. But as I said, if you've done your commissioning, Linac View is a great option for QA. Linac View did find some MLC leaf parking position errors that the detector array did not find. These leaf parking position errors did not impact the dosimetry, and they were reported to the Linac vendor. And so I will say that the detector array had, some values that were lower here because they did, in fact, find this couch issue, which Linac View did not, but it found different errors. And then going on for the 30 incorrectly matched plans, the detector array gave gamma pass rates between 4 and 85%. So that's a pretty high number, whereas Linac View's gamma pass rates was between 0.1 and 64.4%. And so there's certainly correlation here. Linac View was a bit more, showed lower values for the gamma pass rates for the incorrectly matched plans overall than did the detector array. So, just to go ahead and read a few quotes from that comparison, in the conclusion in the abstract is that significant ranked correlation demonstrates the automated log file analysis can be used for patient-specific QA and expedite the adaptive radiotherapy workflow. Ongoing patient-specific QA will be compared with log file analysis to investigate longer-term reproducibility and correlation. Another nice quote down here about some future work that this particular site is going to be working on, potential development into a real-time monitoring system, and then also the log file analysis not only can provide higher throughput due to automation, but can provide faster patient-specific QA feedback to clinicians and physicists. So I encourage you to go take a deeper look at that publication. So what's new in Linac View? So version 3.11 releases this week. It's got some great new features. The best one is the automatic generation of the RT plan. So before it was a manual process, if you found an alert and wanted to, go in and generate the RT plan and recalculate in your treatment planning software, that was a manual process. Now you can set that up to export with each and every plan. And so you can, of course, as I mentioned earlier, go ahead and automatically recalculate all those generated RT plans as delivered. Another really nice feature is that if you get a failure or alert, you don't have to go and open the software and look through the multitude of great information in there to do problem solving. You can initially just look at the report that automatically attaches to the email. And so that's a new feature, that you can get a report attached to your failure or alert emails, and that could point you in the correct direction without any other action. Say if you're working at home due to COVID, and for example, you get the alert on your phone, having dinner, you're in the break room, something like that, you can just go ahead and open that report and get some good information. We have improved linking of the log files because it is a complex process, and the different Linacs use different methods of delivery. So we have just put in some improvements to the log file linking, and we have some specific RT plan generation improvements, primarily for Monaco and Pinnacle, because we've been working in that area. And then finally, the modulation complexity score can be used to specify the acceptance criteria. There are a good number of other improvements, and we can certainly go over those a bit later. I wanted to just show the software real quickly before I close down. So this is the dashboard for Linac View. This is what would be open in the Linac control room. What you see now are a few plans that I put into the system earlier today. You can see that they all passed. These are treatments from multiple different daily sessions. You can cursor over the pass so that you can get additional information on the metrics that are reviewed. You can see that the auto RT plan was exported for all of these cases. And then you see over here that it's the default treatment type. This was a feature that we put into a previous release, is that you can pick up a selected analysis template based on several different criteria. And for these particular plans, we just used the default template. So now I wanted to go ahead and show you how quickly the analysis occurs. I will put into the Linac View software 5 daily sessions, so that you can see how quickly those daily sessions analyze. You can see the log files from day 1 is received. You can see that it has a treatment type called Elekta complex. And so that for this particular case, there is a parameter that is being used to select the particular session. So in short, there is a wealth of information in your log files. Linac View maps the RT plan control points to the log file data. There's a fluence comparison, there's planned versus delivered, The log file analysis is more sensitive in detecting errors compared to detector arrays. There's higher QA throughput, and LinacView version 3.11 has lots of new features, including auto plan generation and reports included in the email alerts. So if you have any questions, go ahead and type them into the dashboard. I'll go ahead and open that up and see if there are any questions. So thanks for your time and attention. If you do have any questions that you think of later, please let me know, and I will be happy to answer them. Thanks, and have a great day.